Let us solve one more problem. So here the device parameter is given as Kp is equal to 0.2 milliamps per volt square, right? And Vt again minus 0.8 volt, right? What we have to find is, as usual, VSD and ID. So what is your VSD? What is our ID? Right? So as usual, we find VG, gate voltage. Here to here VG. Here gate current is 0. So VG is, I apply voltage divider rule. Total voltage 10 multiplied by corresponding resistance 60K divided by total resistance 60 plus 20, 80. So it is 7.5 volt. Next we find VSG. VSG is VDD minus VG. So 10 minus 1.5, it is 2.5 volt. Right, again what we have to do, we have to assume that let MOSFET be in saturation. MOS is in saturation, and with that assumption only we have to start the problem. So ID is equal to Kp VSG plus Vt square. Right, so ID Kp is 0.2, VSG just now only we found it is 2.5, Vt is again 0.8 minus 0.8 square. If you simplify, what we get is 0.578 milliampere. So we got IT is 0.78 milliampere. Next we find VSD. VSD is nothing but VDD minus ID RD. So VDD minus RD, VDD is 10, ID is 0.578 milliamps. RD is, as per the problem, it is in 15 kilo ohm. RD 15 kilo ohm is given here, right? This is our RD, drain resistor. Okay, so this is 15 kilo ohm. So what we get is VSD. VSD is 1.33 volt. Whether, next we have to check whether our assumption is right or wrong. What should be the condition? We assumed the circuit is in saturation. So for saturation, VSD must be greater than VSG plus VT. What we get? VSD 1.33, right? VSG we got as 2.5 and VT is minus 0.8, 1.7. So 1.33 is less than 1.7, so our assumption is wrong. Assumption is wrong. That means circuit is in not saturation condition. That is, MOS is in non-saturation mode, right? So MOS is in non-saturation mode. So what I am going to do, I find a ID again. For non-saturation mode, ID is given by Kp into 2VSG plus Vt square Vt into VDS minus VSD or VDS VSD minus VSD square. Everything we found. Kp is given in the problem, Vt is given in the problem, VSG we found, VSD we found. So if we simplify, what we get is ID, it is square root, so we will get two values for ID. One is 0.568 milliampere, or another one is 0.5163, right, milliamps, right? So these are all the two values we will get. Okay, so next what we have to do, we have to simplify this, right? VSD value we can put VSD, we should not substitute ID value here, right? Instead what we have to substitute, VDD we know, RD we know, ID we don't know. So instead of VSD, what we have to substitute is, VSD is nothing but VDD minus ID RD. VDD value we know, it is given in the problem, so it is 10 volt. ID, RD is 7.5, so minus 7.k. This only we have to substitute. That's why So when you substitute IDD 10 minus 1.5 ID whole square, we will get 2 ID squared. If you simplify, what we get is 2 ID. So we will get 0.568 milliamps and 0.5163 milliamps. So let us assume this ID and find VSD. For this, VSD is 1 VDD minus IDRD. VDD, ID, RD and all we know. So ID is substitute, what we get is 1.48 volt. Here VSD, if we substitute 0.5163, what we get is 2.55 volt. So out of this, which ID is correct, which VSD is correct, we have to conclude. So we know the device is in non-saturation. Non-saturation means VSD must be less than VSG plus VT, right? So here VSD is 1.48. VSG already we found 1.5. Sorry, VSG 2.5, and VT is 0.8, 1.7. So yes, VSG is less than 1.7. So this assumption is right. So our VSD is 1.48, final answer, and ID is 0.58 milliamps. Let us assume the same thing here. Here ID is 0.5163, VSD is 2.55. So VSD is 2.55. VSG we know 2.5, VT 0.8. So 2.5 is greater than 1.17. So it is in saturation mode, but originally device is in non-saturation mode. So this one is wrong. This one we will choose. So this is also wrong, right? So final answer is ID is equal to 0.56 milliamps, right? 0.568 milliamps, and VSD is equal to 1.48 volt, right? Thank you.